Hello guys, welcome back to my channel, The Boy. It's another Simulkuy video, and in this episode I will be talking about variation of fit composition using sensitivity analysis or case studies. Okay, so before we start, I will remind you to subscribe this channel. Don't forget to hit the like button and share this video if you think that this video is useful for you. Okay, so let's start. So now I will using any kind of files actually. In this episode, I will be using one stream with a composition of equimolar acetic acid and ethanol. You can use any kind of stream with any kind of composition. Yeah, it doesn't matter actually. We want to study the method. What makes this sensitivity analysis is challenging? Why I need to make a special video on this because if we want to put the composition, we need to put it as a whole. Yeah, as a whole in this page. Yeah, we cannot directly change like this because they need to have the normalization, yeah, calculation to make sure that the total of the mole fraction is equal to 1. How if we change the basis, yeah, into, for example, mole flows? If I change this, still, yeah, you need to have the uh, this page first. Okay, so that what makes the calculation more challenging. Okay, so for example, if I directly use the normal way how I do it, yeah, this we put in all. Okay, like this. Then I will try to vary the composition of acetic acid and ethanol, and I want to know the correlation with the saturated liquid temperature. Okay, now I will go to the case study. Okay, okay. So if we use the previous method, yeah, from the previous video, so we will make it like this. Previous method is okay. We'll put this as independent and temperature as dependent. Now I will put the low bound 0 to 1 with the step size, for example, 0.2. Same with ethanol. Okay. I think we should, yeah, we should make it like this. Okay. And you will see a 144 number of states here because 622. Okay. So we press that, then click result. Okay. So from the results, you could see that we able to run, but I need to include also the ethyl acetate and also H2O, which actually I don't really want it because it is 0 in my current condition. My feet don't have any ethyl acetate and also H2O. But I still need to put it. Okay, so how if I don't put the ethyl acetate and also H2O? So I exclude as independent variables. Okay, so we will have this error message. Some entries are missing for compositions of stream fit. Stream composition may only be used as an independent variable when all entries are specified. Okay, so this error message really emphasize how we should do it. So we need to add all compositions if we want to use it as an independent variables. Okay. So how if I want to only vary the acetic acid and also ethanol without vary the ethyl acetate and H2O? For these conditions, we can use the another type of sensitivity analysis. It is called a discrete type. Okay. For example, I want to have a 6 states. Yeah. So by using the discrete type, we can really control of what compositions that we want for each state. For example, I want to make it like this. 1, 0 0.8, 0 0.6, 0 0.4, 0 0.2, 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1. So for the other H2O and ethyl acetate, I will make it 0. Okay, like this. Okay, then we press that. Okay, now you can see that we can have a better, yeah, a better result. Yeah? Okay, because we can directly run the compositions that we want to run. Yeah, without having another compositions at the acetate and also H2O. Okay, the last option that you can use, but I still prefer the previous one, this discrete option. But if you uh, want to have another alternative, I will tell you, instead of using the mole fractions, because you know, if we use mole fractions, we need to check whether the total is 1. So we can change the basis, for example, into mole flows or mass flows. I will use mole flows in this case. So as a starting point, I will put 100 and 100. Okay, then I will delete the mole flows here. Yeah, this. Okay, then we can crack this with the temperature. Okay, and then for case studies, you can add the molar flow as the independent, while the temperature is dependent. Okay, yeah, view. Now I want to vary it to 500, the subsize of 100. Okay, start. Yeah, with using this method, we don't need to add ethyl acetate and also H2O. Yeah, it will not have causing any error. Yeah, because our basis is not the fraction, but molar flow. But what is the downside of this method? The downside is we will have some unused points. Yeah, for example, like this, we only vary the ethanol from 100 to 500 without vary the acetic acid. In our case, because we want to check the effect to the temperature, yeah, it will have no effect because in the terms of fraction, it will have the same molar fraction, the pure ethanol. Okay, the same with the variation of acetic acid. Yeah, we will find it. Yeah, like this. Yeah, this and this. Yeah, we'll have the same saturated temperature because it is actually the same one fraction is equal to 1, yeah, acetic acid fraction. Okay, so for me, I will prefer the previous method using the discrete because I can control what compositions that I want. To make that method easier, you can prepare an Excel file so you can directly paste in the composition without specifying one by one, especially if you have a string with a lot of components. Okay, so that's it for this video. I hope this video is useful for you. So see you at the next episode. Bye bye.